Hey, Theodore here. In this video, I'm going to be showing you how to create a token, and I'm also going to be walking you through me actually creating a token while explaining some of the stuff that you might not understand. So the first place we're going to go is this place called remix.ethereum.org. You want to make sure that it's exactly remix.ethereum.org because there's a lot of websites that look like this that steal your crypto. So I've double checked, this one is remix.ethereum.org. And the first thing we're going to do is create a new smart contract. So right here where it says contracts, we're going to go ahead and click on that. And that'll open up 3 smart contracts that are already created for us. But we don't want to use these. So I'm actually going to right click on this contracts right here and click new file. Now I'm going to call this one token.sol, which stands for Solidity. I'm going to push enter and it will actually open that file up for us. So right now, we are in something called an IDE. IDE stands for Integrated Development Environment. So this is actually ran inside your web browser, and you can test your Solidity code here. So before I go into the specifics of what code we need to type out here, I want to teach you a little bit about how a token actually works on the Ethereum virtual machine. So tokens are actually really simple. I've got kind of a table here where we've got addresses and then we've also got balances here. And literally what a token is just an XY table of these 2 pieces of data, where you have someone's account, this is their wallet address maybe, and then their balance of how many tokens they actually have. So let's say I start off with 50 tokens. This table would look like this. Now, let's say that I transfer 2 tokens from me to Basil. What it looks like on the chain and in the code is that I simply take 2 tokens from 50, so now my new balance is 48, and now Basil's new balance is 2. This is what is stored on the blockchain. It's nothing too complicated, it's not a literal token, it's just a database of someone's account and their balance of a certain amount of tokens. So for example, if I wanted to send you 40 tokens, they would deduct 40 from my balance, which would leave me with 8, and then they would add 40 to yours, which would give you 40. And this is exactly how tokens work. So now that you have a rough idea of how tokens actually work, that they're just a list of addresses paired with a balance, let's go ahead and talk about something called OpenZeppelin. So OpenZeppelin is this company out there that basically makes a bunch of money by doing security audits. However, as a way to advertise for free, because it's kind of hard to advertise as a crypto company, what they do is they give us free contracts that they've developed and audited to make sure that they're safe. We can use them absolutely free. And so that's what we're going to be doing to create this token. We're going to be using the code that OpenZeppelin has already created so that we know there's already been a bunch of eyes on this code and we don't have to worry about vulnerabilities. Another thing that OpenZeppelin does is they abide by standards. So we know that when we create this token, it's going to abide by the standards of all the other tokens out there. So you can go to a place called GitHub and view all of their different free contracts. The specific one we're going to be looking at is a token contract. It's called ERC20.solidity. And so this is the actual file that it takes to create a token. Now, we're not going to be copying and pasting all of this code, and you might not understand all of it. But technically, you don't need to launch a token. So if we go back up here to the top and we copy this URL, this GitHub address, we copy it and we bring it over to our Remix IDE. We'll just paste it in there like that. We'll leave it for later. Now, the first line of code that we're going to be doing is something called SPDX-license identifier. And I'm going to be using MIT. And this single line of code right here is started with 2 backslashes. And that means this is a comment, which means it's not a real piece of code. It's not doing anything. It's just letting other people know how they can use our code. Now, the MIT license basically says that anyone else can use our code. And if you take a look at the OpenZeppelin contract for a token here, you can see they've also used an MIT license, which means we're free to use their code. So let's go back to the editor and we'll add in our second line of code. Now, the second line of code is going to be telling Remix, which is this IDE, this tool, this online tool that we're using, what version of Solidity to use. And it kind of is a little weird how you declare this, but you say Pragma Solidity, and then you declare the version number. In this case, we're going to be doing 0.8.13, and then we end any line of code with a semicolon. That lets Solidity know that we're done with this single line. So, the third line of code that we're going to be using is actually going to be using this GitHub link right here. So we're going to go ahead and copy it and remove it from there, and we can move everything else up to the top. Now our third line of code is going to be importing this Open Zeppelin contract so that we don't have to write all of it ourselves. And you do that by doing import, and then you use double quotes, and you put the link inside of there. And remember, we've got it in this line with a semicolon. So now we've got 3 lines of code, although technically one of them is a comment, so it's not really doing anything. The second one is just telling our compiler what version to use, and our third one is literally importing someone else's code. The next line that we'll be doing is actually declaring our smart contract. So let's go ahead and leave some white space there so that it looks a little nicer. We'll do contract, and then what we'll do is we'll name our contract. Now I'm going to be calling this Theodore's token. Now Theodore's token is actually going to be utilizing this GitHub contract up here, this Solidity file of an ERC20 token. And the way that we use that code is we say contract Theodore's token is ERC20. And the reason we say it is ERC20 is because if we go back to this code here, we actually are saying that our contract is actually this contract too. In other words, it's saying that we're copying all of their code. Now, this specific code here actually takes in 2 arguments. This means things you give it that it does with. And in this case, the 2 arguments we're going to be giving it are actually the token name and the token symbol. So I'm just going to do token name as Theodore's token. And then the symbol, we'll do a comma, and then the symbol will just be TT for Theodore's token. And so now we've ended this line of code, but we need to tell Solidity that this contract has some data. So we can open curly brackets, and you can see that it actually automatically ended our curly brackets for us, and we can push enter a couple times. So now this is 8 lines of code, and if I were to deploy this, this would be a real token. In fact, that's what I'm going to do next. So if I do Control S, it will actually compile this project. And what that means is it takes all of these human-readable words and puts them into something called bytecode so that the Ethereum virtual machine can actually read it and process it. You'll see here that I got an error. It even tells me what the error is. It says source file requires different compiler version. So if we go over here to where this 1 is, this red circle, you can see that our compiler is set to version 0.8.7, and we told it we're going to be using 0.8.13. So the simple fix is just to change this to 0.8.13. And now if we do Control S again to recompile, you'll see that it compiled successfully. There's a green check mark right here. Now, let's actually put this on a blockchain. In fact, I'm going to be using Polygon. So this tab right here is called your deployment tab. And right now we can deploy it on a virtual machine. I'll actually show you how to do that really quick. We have a virtual account here that's set up with 100 Ether. And this is the contract that we want to deploy. We could deploy any of these other contracts because we've imported them as well, but specifically we want to deploy my token, Theodore's token. So let's go ahead and click the deploy button, and you can see that there's a green check mark here that we have actually deployed this token. So if you go down here and click this little drop down button, there's a bunch of functions and other things that you can get data or input data about this specific token. So for example, we could get balance of our account. So if we click this icon right here, copy account to clipboard, it copies our account address and we can put it in here, and then we can simply click this button to call balance of, and that will give us our balance of how many tokens we have, which you can see are 0. We don't have any tokens. So we've basically created a token. However, there's no tokens out there. We haven't minted any tokens. So now I'm going to write something called a function that allows us, the creator, to mint ourselves some tokens. So let's go ahead and do function. And I think I'm going to call this one, let's call it mint50. Mint50. We'll do an open parenthesis and then a close parenthesis. And then we have to tell Solidity who can see this function. In this case, I'm just going to say public. We'll open our curly brackets and we'll end our curly brackets. And something I like to do is to take both of these, highlight them, and then push the tab button. That way our curly brackets kind of line up and we don't get confused. So now we have a function named mint50 that we can use. However, right now it doesn't do anything. So let's make it do something. We'll do something called _mint, which is a function that Open Zeppelin has written. In fact, if we scroll down here just a little bit, I'll make it a little bit bigger so everyone can see. There should be a function in here called _mint that basically mints you some tokens. There it is, _mint. And this is the code of what it does. You can read it if you understand it. And if you want to understand this and you don't, you can go to whiteboardcrypto.com and join the waitlist for my Web3 Portfolio Builder Bootcamp, which is basically a 12-week program that teaches you how to completely understand all of this code and actually create any dApp that you want to create. Anyways, back to our code. We're going to be using _mint. And you can see that this function, whenever we call it, what it's going to do is whatever is inside of these curly brackets, which is basically calling this function _mint. However, if we go back to _mint, you can see that we have to give it two things. We have to give it the account that we want to mint tokens to, and the amount of tokens that we want to mint. So let's go back to our IDE and give it those two pieces of data. The first piece of data is going to be called message.sender, and this is basically a quick way to say whoever is calling this function is the one who should get the tokens. That's who message.sender is, whoever is calling this function. So if you call it, you'll get the tokens. If I call it, I'll get the tokens. Next, we're going to do a comma, and let's say we called it mint50, so we'll do 50 tokens. However, in reality, Solidity does not have decimals. Instead, they use very large numbers, and then we let other applications add decimals to that. So for it to actually be 50 tokens, we need to multiply it by 10 to the power of 18. However, in Solidity, instead of this little caret here for exponents, we just do 2 asterisks. So now, if we click on this little X here and we basically get rid of that old contract we just wrote, and we go ahead and click the deploy button, and we Control S to recompile, you'll see that we get an error, and that error is because we do not have a semicolon at the end of this line. So let's go ahead and Control S again and see if we get any errors. We don't, we got the green check mark. So now let's click this deploy button to actually deploy this new contract. I'm going to go ahead and copy my address, and I'm going to put it in balance of to see how many tokens I have. I have 0 tokens. Now, I want to use this function mint50 to see if I can mint myself 50 tokens. So I'm going to go ahead and click mint50. You can see that a green check mark showed up, and it successfully went through. Now, if I click balance of again, this should be a very large number starting with 50. And it is. So if I take this number and I copy it, and I open up, I think it's ETH converter. Yeah, ETH-converter.com, and I put this value in as way, you can see it equals 50 tokens. Like I said, Solidity does not like decimals, so we have to do this. Now, before I end this video, you might be saying, can anyone call this function and mint themselves 50 tokens? The answer to that is yes. Yes, they can. We can go up here, we can change our account to account number 2, and they can also mint themselves 50 tokens. It went through successfully. So how do we stop this? Well, we apply something called a modifier that only certain people can use this function. OpenZeppelin has a modifier called onlyOwner, which we actually import whenever we import the ERC20 token. So let's go back to our IDE and add a special line of code called a modifier that is named onlyOwner. Now, only the owner of this contract, only the person who creates it, is allowed to call this mint function. So let's go ahead and remove our old contract. We'll do Control S to save this and compile. And you'll see that we get an error that we can't use onlyOwner. So now we have to import something that allows us to use onlyOwner or write it ourselves. And because this isn't the entire bootcamp, I'm not going to show you how to write it yourself. But what we can do is go to OpenZeppelin, and basically I'm going to paste in their ownable contract here, which is the code that you would need to write yourself if you wanted something to be ownable. So I'm going to go ahead and copy this code, and we're going to be importing it as well. So import with our semicolon at the end there. And because we want this to also be ownable, we just need to add this to what Theodore Tokens is using. So Theodore's token is using an ERC20 contract. We can also say that it's using an ownable contract. And when we compile this, we should get the green check mark just like we just did. And so now we can deploy this contract, click the drop down button, and mint ourselves 50 tokens. Now if we copy our address and put it into balance of, and we paste this here, we should see that we do have 50 tokens. And now if we change our address from account 2 to account 3, and we try to call mint 50, we should get an error. So let's go ahead and click this button, and you can see that we got an error. The error is caller is not the owner. So now other people cannot mint themselves tokens. Cool. So how do we actually get this onto an actual blockchain? Well, I'm glad you asked. Let's change this environment right here. We'll click on it and we'll go to injected provider-metamask. For some reason it's not working, so I'm going to remove our previous contract and refresh the page. We'll reload. We'll go to contracts, open up our token.sol that we were working on. We'll go to our compile tab, Control S to compile it and see if it works, and it does. So now let's try to change from Remix VM to injected provider, and MetaMask will pop up, and we should say yes to this. I want account 1, which has Tinmatic in it. We'll connect it, and we should be good to go. So I'm going to go ahead and click deploy here. MetaMask will pop up asking me to deploy this contract. I'm going to click edit and I'm going to speed this up. Basically, this works as a bidding system. I'm going to go ahead and click edit and try to speed this up. And when that goes through, we will have successfully launched our very first token. It went through. I'm going to go ahead and click on it. It'll open up in Polygon Scan, and right now it's not showing up, but in a couple seconds it should. Let's refresh the page and see if it shows up, and it does. You can see who created the contract. You can see the actual contract itself right here, how much it cost to deploy this. So this was around 50 cents to make this token. Polygon Scan doesn't know this is a token yet, so let's go back to our IDE and click this drop-down button on our newly minted Polygon contract, and let's mint ourselves 50 tokens. Once that goes through, we can then go back here and refresh the page to see if it updates. And there we go. You can see that we've minted 50, or called the function mint 50. And if we go into this transaction, you can actually see that we went from basically nowhere into this account for 50 of Theodore's tokens. Usually when you're minting tokens and you're creating new ones, it shows from null. So we can actually click on this and see Theodore tokens information, that there is one holder, that there's only been one transfer, and there's 50 total Theodore tokens. We can also sort by holders, and we can see who holds the most, which is the account that I just minted them to. And if I wanted to, I could send these tokens to anyone else. So wrapping this video up, we created a token in less than 10 lines of code. This is actually a rather safe token as well. We also deployed it so that it was on a real blockchain. If you thought this was interesting and you'd like to learn more about the Ethereum virtual machine and writing smart contracts and even building entire dApps, you can join the waitlist for my bootcamp that's going to be launching really soon. You just go to whiteboardcrypto.com, enter your name, your email, and you'll join the waitlist. Tomorrow, I'm going to be sharing a video where I basically create a bunch of meme coins that have really unique abilities. So, for example, I created a token that you can only move one token per day. I also created a token that you can't sell for an entire year. There's also a token that if your account is dormant for more than 24 hours, someone can steal your crypto, which also means if you find other accounts that are dormant, you can steal their crypto. They're definitely meme coins though, and to be quite honest, I coded them just like I coded this. Except the lines of code that I added are a little bit more technical, and a lot more thought went into them. I highly recommend joining the waitlist. I really hope you enjoyed this video, and most of all, I hope to see you in tomorrow's video where I show you some meme coins that I've built. Thanks for watching, and I'll see you guys later.